Guys, this is the Academic Chemistry Chapter 2, Section 2 notes on mixtures. So mixtures are pretty much something you're familiar with, but let's talk about what we did last section before we talk about mixtures in the chemistry sense. So last time we talked about pure substances. So let's review what a pure substance is. Pure substances have the exact same material repeated over and over at the atomic level. There are two types of pure substances. So there's elements, which have only one type of atom in the whole sample. So for example, tungsten. If you could look at tungsten at the atomic level, you would see just all sorts of tungsten atoms, and they're all individual, so none of them are bonded together, and they're all exactly the same. The other thing that clues you in that it's an element is it's on the periodic table. So if I ever say, is something an element or not, it's kind of like a multiple choice test because you have all the elements there for you on the periodic table. The other type of pure substance is a compound. So compounds have the same ratio of atoms bonded together. So here is ammonia. If you look at every single part of this sample, it's got one nitrogen bonded to three hydrogen. So every single one of these are exactly the same. The difference is these aren't alone, right? In tungsten, you just had one atom hanging out by itself next to another atom hanging out by itself. But in ammonia, it's a compound, so you have multiple atoms together and they're bonded, and then they all hang out together at the same ratio in each bit. Another thing that clues you in that it's a compound is it has a chemical formula. So ammonia is NH3. If it's ever not NH3, if it's anything else, then it's not ammonia. It always has the same concentration because the concentration would have to be 100%, right? So it never, ever, ever changes. No matter where you get a sample from ammonia, it should be the exact same if it's pure ammonia. So those are your two types of pure substances. So let's talk about what a mixture is. Mixtures are made up of two or more pure substances. So a mixture is actually pieces of pure substances put together. So these things are in the same space, but they're not chemically bonded together. So here's a little picture to look at. Notice here you've got an element. Here is a compound, even though they're exact same atom, they're bonded together, so that's a compound. Here's a compound, and you have three different things in this whole area. So this is a mixture. It's not the same throughout, and things that aren't the same aren't bonded together. Most matter in the universe is considered a mixture. So think about anything around you, it's probably most likely not a pure substance. There are some pure substances, but most stuff is made of mixtures. All right, mixtures, another key thing is they can be separated by physical means. So the pure substance making it up is never going to be changed when you separate it. We're going to actually do a lab where you are going to separate a mixture. So you'll see that you start with the same stuff that you end with, you just do physical changes to separate. There are two types of mixtures, and the first one is a heterogeneous mixture. Now you've heard the prefix hetero before, like heterozygous you heard in biology. It's when you have two different alleles for the same gene, or it's just hetero means different. So heterogeneous mixtures have clearly separated phases or parts that are different when you look at it. So you can tell that there's a difference in the stuff that makes it up, because what a mixture is when it has things that are different coming together in the same area. If you can actually see those differences, then it's a heterogeneous mixture. So let's look at some examples of heterogeneous mixtures. So the first would be oil and water. Notice you can clearly see the water, you can clearly see the oil, so it has two separate phases, right? It's got the water phase and it has the oil phase, and they're totally different from one another. So that is a heterogeneous mixture. These are in the same area, but they're not bonded together, so it's a mixture. You can see the difference, so it's a heterogeneous mixture. Pizza is a really obvious example of a mixture. You've got cheese, you've got bread, you've got maybe some pepperonis. But the big thing is none of these are bonded together, and you can clearly see the difference between them. So when you have multiple things that aren't bonded together, that's what makes it a mixture. And when you can see the difference between the things, that's what makes it heterogeneous. My last example is kind of one that some kids struggle with. So a heterogeneous mixture is also anything that's alive, any type of tissue. I mean, if you think about your whole body, obviously you're a mixture. Like my fingernail is very different than my eyeball. So that's different substances and they're not bonded together, right? I can cut my fingernails and that doesn't affect my eyes at all. They're not together. If you even just have a small little sample, like say you have a vial of blood, that blood is made out of cells, and the cells are different at the atomic level based on what part of the cell. So I brought in an animal cell here, if you remember from biology, and you can see it's got the nucleus, the endoplasmic reticulum, the mitochondria. All of that have different atoms that make it up. So you probably have like a lot of calcium hanging out in the endoplasmic reticulum that is used for various cell purposes, and you're not going to have that calcium storage anywhere else. So it's different over here than in other places. You have, a bunch of DNA inside the nucleus. You don't have that material in other places, so this is clearly a mixture. The other type of mixture is a homogeneous mixture, and the prefix homo means the same. Like you had in biology, a homozygous, which is when you have two of the same alleles for the gene. But a homogeneous mixture is when a mixture looks the same throughout, or it's all uniform. So when you see this mixture, it looks the same all the way through. It's really easy to confuse this with a compound when you're first learning these, so this is something to keep in mind. Remember that mixtures do not have a set ratio of substances. So if the concentration or the variety can be changed, even if it looks all the same, it's a homogeneous mixture. So what do I mean by that? So let's look at my first example, milk. Milk is a mixture. It's got proteins, it's got some lipids, it's got all sorts of different stuff in it that's mixed together. You also know it's a mixture because it comes in 1%, 2%, whole milk, skim milk. So you can change the composition. If it were a compound, you wouldn't be able to change the composition, but since you can change the composition and it's the same thing, it is a mixture. Another example is steel. A lot of people don't know that steel is actually a mixture of different types of metals, and you can change what types of metals you use based on what you need the steel for, maybe how strong you need it, if you need it to like really resist rust or if it can rust a little. That depends on what type of metals you're going to put in, but none of them are bonded together. Metals have a really cool property where when you put metals together, they interact with one another without actually bonding, and they just kind of hang out in the same space. So steel is a mixture because none of those metals are actually bonded together. And my last example is anything that says a solution. So in chemistry, you're going to make different concentrations of solutions. Maybe you have a really strong concentration of acidic solution, or you have a weak concentration of acid solution. Since it says solution, that means it was mixed with something. It's generally going to be mixed with water. Sometimes it might be mixed with an alcohol, but typically it's mixed with water. So it's not pure anymore. It's now a mixture. All right, this is a chart I just like to use to keep things in mind. Remember, all things that take up space and have mass are considered matter. If it's only made of one type of substance, it's pure. If there's multiple substances, it's a mixture. All right, if it's only got one type of substance, if it's pure, if it's on the periodic table, it's an element. If it's not on the periodic table, but it has a chemical formula, then it's a compound. If it's matter that isn't pure or it has a variety of options, like different concentrations, or you can clearly see there's different stuff in it, it's a mixture. A homogeneous mixture looks the same throughout. Some people say homogeneous, by the way, but I've always learned it to be homogeneous, so that's how I say it. If you hear someone else say homogeneous, it's the same thing. So that looks the same throughout versus heterogeneous looks different throughout. All right, have fun identifying the types of matter and be sure to ask your teacher if you have any questions.